Hello. All good? Let's go. Okay. Hi, good afternoon, everyone. Welcome to this session on automation of wind farm O&M. How close are we? So this hopefully should be quite an interactive session. We're going to present some innovation that's ongoing in the area of automation for offshore wind O&M. Hopefully get some feedback from you as an audience through Slido. Seems to be a big theme throughout this whole conference. And then we're going to do some demonstrations about the kind of work we've been doing at Catapult with our test turbine and some of the drones that we're using there to investigate those for blade inspections and other forms of turbine inspections. So I will be your main chair for the next hour. In your conference program, there are 3 sessions that are all part of this section, and they hopefully will run seamlessly throughout, aided by my colleagues, David Thompson, who is one of the engineers, and Claire Canning hiding back there. She's had enough FaceTime today. You might have seen her this morning. She is going to be running the Slido for us back there. So, okay, so let's fire in. So as I said, we have 3 sections to this session. The first is looking at state-of-the-art technologies for automation with some of the SME case studies. So we've been working with a lot of SMEs. Some of those are here today on applying autonomous systems to offshore wind. So we'll try and showcase some of those. And then we'll have an interactive polling and discussion session. So we'll be using Slido, looking to feedback some of your thoughts, hopefully. And then finally, we'll look at the application of using drones, UAVs, unmanned aerial vehicles for turbine inspections, and we've got a bit of a simulator here. So before I start, I'd just like a quick show of hands. So who in the audience is involved in developing autonomous systems or interested in applying autonomous systems to offshore wind? Okay, just a couple. Okay, all right, good. Well, hopefully this is an informative session, but hopefully you can also take part as well. So as I said, it is supposed to be interactive. So we're using Slido. So if you attended the morning session, hopefully you're aware of Slido. But if not, you can run this from your phone. You just have to log in. You just have to insert the URL into your browser and then use the code there, ORE Robots, which will allow you to access the panel. So this is hopefully where I see everyone frantically whipping their phones out and logging into Slido. Okay, all right. So the code will be up in the top right hand of each presentation slide in case you're a bit shy right now. Okay, so what we're going to do is we're first going to test Slido out. We're kind of flying by the seat of our pants here a little bit. We've not had any chance to trial this, so we just want to make sure that the Slido is operational. So we have our first poll of the day that we'd like you to take part in. We want to know, well, can you estimate how many drones will be in UK skies by 2030? It's a bit of a speculative one, but I think we've got one answer, maybe, unless everyone is keen on 76,000. I'll give it a few seconds. Oh, yes, here we go. The poll is in action. Split 50-50. Any more takers? Okay, well, at least the poll works. So we have a split here. Actually, this is in a recent report, I think it was by PwC, who've estimated that there will be 76,000 drones in the skies by 2030, which is in some ways great, but in some ways quite scary as well. I think we're really evolving from these being seen as sort of playthings, toys, to being used on an industrial scale within the industry. So hopefully, you know, these are quite small. If you've seen the ones on the front stand by Tech, so that's some serious beasts there. So you know, the scale of these things is definitely getting higher, and we're scaling up as an industry. Okay, brilliant. So before launching into some of the technologies, I want to first introduce Catapult, who my colleagues and I work for. So we are the UK's Technology Innovation and Research Centre for offshore wind, wave and tide, so offshore renewables. We were set up around 5 years ago to help the industry reduce costs, but also deliver maximum UK economic benefit. So that's really our 2 main goals. By helping the industry to reduce costs, hopefully that opens up lots of opportunities for innovation, and the UK can really capitalize on that by developing, you know, cost-effective products and services. So we support both industry end users, but also SMEs, agile innovators, and all other companies looking to access offshore wind. So we have a number of sites split across the UK. Our main sites are in Glasgow and Blyth. Glasgow we have mainly offices, but Blyth we have a huge collection of renewable test assets where we can test blades, drivetrains, electrical infrastructure, subsea technologies, metrology, all sorts of things. And then in Leavenmouth we have a 7 megawatt demonstration turbine that we use for demonstrating things like this. And then across the country we also have some regional offices as well. So that's us. We're an independent organization and we're here really to help best serve the industry and maximize the opportunities for the UK. Okay, so getting into the thick of it. So I want to first introduce, you might not be aware of some of the technologies. I notice we've got not too many developers of autonomy in the audience. So first do a bit of a 101 on state-of-the-art technologies for automation with some SME case studies. Okay, so hopefully this slide illustrates some of the opportunities here. So here we have a very crude schematic of an offshore wind farm. You have your turbines, your offshore substation, your cables, export and array cables, and your onshore substation with your seabed. So let's just kind of look at some of the opportunities we have here. So seabed surveys, if you're aware of offshore wind, these are done during the project development and also during the operations phase. Trying to understand any movement of the seabed and helping to plan major O&M interventions, such as using jack-up vessels. So for doing subsea surveys, this is primarily done by vessels, a lot of manpower. Now there's a huge opportunity to use automation here. We could use autonomous underwater vehicles have been developed in other sectors, applied in oceanographic studies, searching for wreckage, lost planes even. These have been used. And also in oil and gas, they're starting to be used as well. So these are autonomous vehicles, much like an ROV that tends to be tethered to a vessel, but rather than being tethered and operated remotely, these are fully autonomous systems that have full autonomy and can be deployed from the shore, from a vessel, or even have permanent residency offshore. So these are really promising for doing subsea surveys and inspections of foundations and cables. And then a complementary technology is, moving on from left to right, is the autonomous vessels themselves. So vessels are largely manned. These exist already, unmanned vessels. They've been used in defense, highly used in defense. And some companies, such as autonomous surface vehicles, are looking to apply these to offshore renewables. So these are unmanned boats that could be conducting surveys, supporting underwater vehicles, or even transporting people and parts themselves. And then if we look at the actual infrastructure as well, again, we can use autonomous underwater vehicles for not just doing surveys of the seabed, but actually doing direct spot checks, inspections of the cables, the integrity of the cables, and also of the foundations. And then probably the most well-known technology are these technologies themselves. UAVs, they've probably had the most traction so far in offshore wind because a lot of these are commercially available technology. They've been used in other applications, and there's a lot of use of unmanned aerial vehicles for doing aerial inspections, so inspections of blades, towers, nacelles, etc. So a huge opportunity there. And then finally, something that is relatively untapped and more novel is using what we call internal contact systems. So robotic crawlers with either adhesion or vacuum adhesion that can actually go inside structures, foundations, inside blades, inside nacelles, do inspections, or potentially even do maintenance in the future. Now, we have seen some technologies already capable of doing that, but that's still very early days for the sector. So here's just a couple of images of some of those technologies. UAV at the top, unmanned underwater vehicle, AUV, in the middle, your crawlers, your robotic crawlers, and your unmanned surface vessels. So there's a lot of acronyms involved in this, and it's really hard to keep up. So hopefully that explains some of the potential in the technologies. Okay, so when we talk about automation, it's not just the hardware, it's not just the physical process of going out and doing the inspection, going out and doing the survey, or even potentially going out and doing maintenance. It's also automation of the data processing. So there's a huge amount of asset data, performance data that comes back to shore, that has to be processed, that has to be analyzed in order to then plan effective maintenance and understand the performance of your asset. And that can be a very labor-intensive and even subjective exercise. Everybody might think differently, everybody might use different systems. So there is a massive opportunity in offshore wind to use automation. Things like machine learning algorithms, digital twins are being used in other sectors. So virtual environments of your asset that you can use to monitor in real time performance, reliability, and also predict future failures. So the automation of the data processing is also something that has great potential. And also in the asset inspection data, for example, blade inspection images, these could be potentially processed automatically. So you get a lot more consistency in the damage classification. So automation is possible for both the hardware and the software data processing. Okay, so hopefully that gives you a good intro to the technologies we're talking about. So now we're going to launch our second poll of the day. So if you could take part, get your phones out, log into Slido. The code is ORE Robots, hashtag ORE Robots. And the first question we have today is, do you see any risks with autonomous systems in offshore wind? So all the things that I've discussed sounds great, but what are the potential risks? So we'll just give you a minute or so to talk about that. Okay, great. Untrained users, definitely. Legislation, for sure. Legislation, so definitely around civil aviation authority. So the real holy grail for drones would be having a system that could be operated fully autonomously offshore with no need to actually go out there, send a vessel or a person to operate. And that's known as beyond visual line of sight. At the minute, the regulations require line of sight, so you can override any incidences. So yes, legislation needs to evolve to enable beyond visual line of sight, where the cost reduction could really come down. Okay, great. So we've got more coming in here. Let's see. Someone's just written risks, which is great. Risks are risks. Maybe elaborate on that one. Bad data. Yeah, so that's a good one. So you're trying to basically go out there, perform an inspection to the same standard as going out there with a human. Say we're doing a blade inspection, that human can get very close to the blade, take a very good picture, and that gives you confidence. Now you need to be able to replicate that with a UAV. The technology is no good, no matter how much cheaper it can be, unless you can produce the same quality of data. So that's a good one. Costs. Yes, so there's going to be potentially a big upfront capital cost with this equipment, but we need to be able to demonstrate down the line how that can then increase the volume of data, reduce the vessel use, reduce the personnel requirement, and bring the cost down. Crazy. Is that crazy untrained users or just crazy as a risk? Bad press, I think, is a good one as well. There's a whole range of companies now looking to get involved. And are they fit to be working in offshore wind? How do you demonstrate that? There's no standards or regulation at the minute, and I think that really ties in with some of the things that your RenewableUK are looking to do to try and generate guidance around this. Great. So downtime, yes. I think hopefully by having systems that are fully autonomous offshore, you can reduce some of that downtime requirement, especially if you can inspect assets that are still operational. And yeah, near misses. So great. So some really good feedback there. I think we'll move on to the next poll. Okay, so we're talking a lot about O&M, but do you think there are any areas outside of O&M that could benefit from the use of autonomous systems? So, just for example, project development, construction, decommissioning. It's not just the hardware, remember, it's also the software side of things as well, the data processing, the analytics, potentially even design. So yeah, site survey is a good one. Something that is done both during development and construction and even operation and maintenance. Any other takers? Any other ideas beyond site survey? No answer is stupid. This is all anonymous. All right, here we go. Wind resource assessment. Yep. So we've could you actually install metrology on this equipment to go and do wind speed measurements? That's a challenge, but met mass costs a lot of money. LiDARs are great, but they're still relatively expensive. So could we have metrology on UAVs or even subsea equipment. Transportation, definitely. I think transporting potential parts. People could, in future, you use robotics to actually do major component replacements. So really serious pieces of kit. Power generation. I don't really know how to. That's a whole new form of electricity generation using autonomous vehicles. But I suppose we don't want to completely write off the humans. We need still a job. So let's go easy on that one. Right. Okay, great. So thanks for taking part. There'll be more of those. Okay, so moving on to the next slide. So we've talked mainly about the technology. You guys have given us some good feedback. Let's look into the actual opportunity. So drill down into the real opportunities that this technology presents for the sector. So, physically we're talking about, the automation of the surveys, the inspections, the data analytics, and potentially even maintenance. And obviously that could have cost benefit. So the real potential opportunity is to reduce costs. If you take away expensive vessels, take away the expensive manpower, you can start to reduce the costs. The weather dependency as well. If you're used to doing any operations offshore using vessels, weather downtime is a significant risk and cost that often the operator has to take on. So reducing the weather dependency, if you can have systems that are less weather dependent or could be even stationed permanently offshore, is a potential opportunity there. Health and safety, you're taking them out of the harsh environment, the risky environment, and it leads on to the third last point there. Bring the manual workforce onshore. So can we replace the high risk jobs with more low risk onshore jobs where a lot of these systems are going to be managed and controlled. Increasing the consistency of data analytics. So there's a lot of subjectivity in using human sort of intervention for data analytics. Using machine vision algorithms, etc., can really increase that consistency and rigor. And there's just some high-level estimations that there is a potential market size of 2 billion per year by 2025 for these technologies in offshore wind. If you think about the scope that you could address from data analytics, inspections and maintenance, that is a big part of the O&M scope, so a massive potential market size. I think the bottom one is a really important point, that the UK government are really getting behind robotics and AI. It's one of the 4 grand challenges that is part of their industrial strategy. So they see this as an opportunity that could transform the UK economy and export opportunities and make us global leaders. So they're injecting quite a lot of innovation money into robotics and AI. That's really spurred a lot of the work that we've been doing. We partner a lot with companies to access funding and then do projects together. And a lot of that has been backed by the government's Industrial Strategy Challenge Fund. So if it's an area you're thinking about getting involved in, there's a lot of support from the UK government for this. So huge opportunities there. Right, on to the next poll. So this is what you're probably all thinking, and it's often the question that comes up. What impact do you think autonomous systems will have on UK jobs? So, you could simply say it will increase or decrease them, or it will completely eradicate them, and Terminator is just around the corner. But what impact do you think it will have on UK jobs? The poll is open. Replace. Positive. Good. So on the positive side of things, yes, I think a lot of people will say, well, you're removing the need for those jobs, but there's the opportunity to create a whole new sector of developers, engineers, mathematicians, operators, people with operational experience in operating these drones, bringing all that onshore and replacing the high risk jobs that are offshore is a big opportunity. So we've got 2 conflicting views. Oh, great, we've got more. Move to more high-tech jobs, I think is a big potential, because the jobs that we're going to have to support these will be more high-tech in nature, but definitely there's potential skills gap here, so the UK needs to get behind this in terms of skills development as well. So I think that's more positive than negative, actually, so quite happy with that response. I think in general, hopefully this will create a new industry in the UK with lots of jobs. Okay, so moving on to the next. Oh, Claire, if you could. There we go. Perfect. Okay, so what is Ori Catapult doing in this space? So, from mainly, as I said, mainly spurred by the influx of government support for this industry. Around a year ago, we started, supporting a lot of companies in accessing innovation funding and delivering projects in this area. And over the course of about a year, we've got about 9 projects ongoing, live projects, primarily R&D projects, working with companies to develop and demonstrate their technology and try and catapult them into the sector, forgive the pun. So, more recently, we thought more strategically about how we best support this industry and help it moving from R&D through to an industrial scale. So this is the program that we have developed. The vision is automation of wind farm O&M, and we're really looking at 3 areas. I'll start from the left here, actually. So technology innovation, so helping the companies to innovate, to develop solutions that meet industry requirements. We have a lot of access to industry. We can ask them, if you were to suddenly replace your manual workforce with an autonomous workforce, what would you need to see in terms of performance, reliability, durability, health and safety, longevity, all those things, and we can then feed that back into the supply chain and say, this is what you need to develop, this is what the industry requires, and then we can help them on that journey. So we can help them to develop the business case for their technology with our knowledge of the sector and some of the costs involved, but then also help them to demonstrate their technology. We've got a lot of facilities that are relatively fit for purpose for doing this type of demonstration work. But if I would maybe jump to the right there, test and demonstration is one of our biggest products. That's one of the largest ways that we can support companies. And we do have a huge set of facilities, but they were never really designed for this purpose. So we're doing a lot of internal investigative work to see how we can improve those facilities and create a proper dedicated robotics test and validation center in the UK. So that's something we're actively pursuing. You can come and work with us now, but in future we should have some much better services to offer in this area. And that links closely into the validation methods. So at the minute, there is no industry guidelines, really, no standards around this, which is in some ways good, not having too much regulation, but in other ways not so good, because how then do you pre-qualify companies? How do you ensure that they can be fit for purpose? So you need those validation methods, those guidance, and those standards. So we want to use the work that we're doing with the supply chain, with the end users, and around the test methods to also develop the supporting validation techniques as well. So that hopefully when this does become a real industrial scale technology and application, we have all the rigor and the necessary assessment in place. And we will be looking to work very closely with RenewableUK on that. So I'll now just talk about 3 case studies, so 3 companies that we're actively working with. Got a couple of videos here, make sure they work. Okay, so this first project is called A-Vision. I spend my life coming up with acronyms for projects, so this is one of those. Quite proud of this one. It stands for Autonomous Vehicle for Inspection of Offshore Wind Farms Subsea Infrastructure. So this is a company called Modus Seabed Intervention. They're a Darlington-based company, UK-based company. They have a fleet of offshore vehicles, so ROVs, trenchers, and the latest addition to their fleet is an autonomous underwater vehicle that was developed by Saab, and they're now looking to apply that in commercial areas, including offshore wind. So we joined up with them some time ago and decided to create a project to demonstrate this for offshore wind. So this video is the system actually being tested in one of NASA's zero buoyancy tanks. So that's not an animation, that's actual real life footage showing the vehicle autonomously inspecting that juniper section there, and it's about to autonomously switch on a valve. So the tech exists, but the project is about de-risking it for offshore winds. We want to apply it in real offshore wind environments, and we want to make sure that it can operate and also collect the right data, data that is acceptable by industry. So it's an 18-month R&D project. The partners include Osbit. So what Osbit are doing is developing a subsea residency station. So this is a subsea garage, essentially, that can be located permanently offshore. which would enable a home or a garage for the AUV to dock with, charge, receive commands, and also transmit data back to shore. So that completely removes the vessel requirement. So it really reduces the cost of the survey. So the objectives are to design and build and test that docking station. This is an example of one of the stations, but that doesn't allow for the subsea charging, is the big challenge. Design, build, and test that at Catapult. So we are a partner in this project. And then we want to demonstrate that AUV for doing a subsea survey and inspection of an operational asset. So we've got 3 industry end users involved in this project: EDF, Energy, and E.ON. And once we have established the methodology, we will be demonstrating this at Energy's Gwyntimore site in northwest Wales. So that's a really interesting project that's been going on for about 6 months now. So hopefully by the end of that, they will be market ready for offshore wind. Well, they already have the technology, but this hopefully will increase their exposure to the industry. One sec. Just get that one on the go. Okay, so this next project is on the UAV side of things. So this is a company called Perceptual Robotics, who are a spin-out from Bristol University, like 4 really young guys who are trying to take on the world with their autonomous UAV for wind turbine inspections. So this is just like one of these platforms, but they're developing all the clever algorithms to operate this fully autonomously. So it can be programmed to go an autonomous flight path and gather inspection data without any manual intervention. No pilot required, just the ability to launch and recover. That is the premise of it. They are, they're some way down that development path, but this project is one we're working with them on to actually increase the autonomy by investigating the potential to deploy and recover the UAV from an autonomous vessel. So this is working with the company ASV, and the idea is you could go out with the autonomous vessel completely unmanned. You'd have the drone on the vessel. The drone could then be deployed to inspect the turbines and recovered by the vessel and come back home. Essentially fully autonomous. So that sounds pretty far-fetched. So obviously a lot of test, demonstration, validation, cost-benefit analysis required for that project. So that's really the scope, is to further develop the autonomous algorithms and demonstrate the technology at our 7-megawatt Livermouth turbine that we'll talk about at the end of this presentation. So partners are Perceptual, ASV, Vulcan UAV, who developed the platforms, and the University of Bristol, developing some of the fancy algorithms. So that's that one. One second. Technical difficulty. Wait a sec. Oh, there we go. Okay, so the final case study is on the project called WASP, which stands for Windfarm Autonomous Ship Project. So I'll just kick off this wee video. Bit of sound behind this one, hopefully it's not too loud. So this has been led by Autonomous Surface Vehicles. They might be here today. Is anyone actually here for Autonomous Surface Vehicles? Nope, okay, never mind. So this is an 18-month R&D project that we're working with them on. And this is really, it's a feasibility project, a very comprehensive and involved feasibility project to help characterize the potential for using unmanned surface vehicles in offshore wind. So look at all the potential applications, try and understand the cost benefit, and try and optimize them for those applications. So the real output will be a roadmap for the integration of USVs, unmanned surface vehicles, into manned vessel operations. We're not looking to completely eradicate the use of manned vessels. We're looking to see how these vessels can support those, especially for far offshore sites, such as Dogger Bank, which has been used as the case study for this project. So projects include ASV, Searock, Holder, University of Portsmouth, and Catapult. Okay. Sorry, this is going a bit slow. Bear with me. Right, okay. So we're now just going to have a short kind of interlude from the presentation to address any questions. So with Slido, it is possible to ask questions. So Claire, are there any questions? I hope so. No pressure, Claire. Oh. Told you we were flying by our seat of our pants on this one. There's going to be some more polls as well, so maybe we'll kick into those. Has anyone actually just got any questions they'd like to ask? We'll just do it the old-fashioned way rather than using the tech. Okay, no worries. Anyone got any questions they'd like to ask at this stage? You can put your hand up and we'll send the mic round. Okay. Go for it, Chris.
Quick question. Are you looking at nanotechnology or nanobots?
So the question was, are we looking at nanotechnology, nanopods? Yes. I would say we don't have any current ongoing project looking at that, but we did a study recently to go out to the main stakeholder groups and understand where they think this technology would evolve, where it is right now, so we could best design our test and demonstration services. And a lot of people said in future we will evolve to using what's known as swarms. So rather than having big pieces of kit like this, swarms of UAVs, small, very cheap technology that can go out and gather more kind of data across bigger spatial resolutions. And I've also heard of some technology, small technologies that can go inside components. So definitely something that we would be interested in, but at the minute, no ongoing projects. So if there's anyone is aware of, please send them our way, because we've got all the know-how in the facilities to kind of de-risk this and demonstrate it. Oh, here we go. Yes. So are you looking at, there you go, nanobots. Are these case studies part of public funded projects? Yes. So these are all projects where we have partnered with a company. We've sort of identified the opportunity, gone to that company and said, look, this technology could be applied in this area. We formed a project and we both applied for public funding. It's the best way that we can work with companies, really, because it provides the grant for the company to develop the tech. Ori Catapult are 100% funded as part of these grants, so any test, demonstration, industry know-how you require would be covered by the grant. And we can usually try and get an industry end user to come on board as an advisor, so you've got an immediate client who's interested in the technology. So the funded route is really a good way to go. And these funding calls are, every couple of months, and robotics tends to always be in scope. So if you're thinking about it, please talk to us about that, because it's a really neat way for us to work together. When will we see autonomous systems in service? So already we're seeing these types of systems, UAVs. I'm aware of companies like Siemens Gamesa and others who are really trying to push towards using automation and reduce the cost of manual service. So by service, with the actual doing turbine service, we could be a long way away before these technologies can actually do maintenance. So going and perhaps changing lubrication oils or actually going and repairing things. But right now, I think in the next 0 to 5 years, we'll start to see these technologies becoming quite widespread for doing operations. So that's the inspections, the surveys, gathering the asset data. Already these are being used for blades. AUVs are just around the corner for underwater surveys. And ROVs, we shouldn't forget, is a form of robotics. They're being used quite a lot, but there's still some human interaction there. So I don't think it's going to be too long before these become more ubiquitous in terms of doing service, especially on the operations side of things. So are you looking at autonomous systems for inside the turbines? At the minute, we definitely are, but we don't have any companies we're working with. And what we'd like to do is work with the companies involved in doing turbine service, who send technicians into doing turbine service, to understand where could we, what are the opportunities for replacing that with autonomous tasks. Those kind of mundane, repetitive tasks that perhaps cost a lot of money and add a lot of risk. What are those areas that we could look to use systems for? A lot of the systems we're looking at are less invasive technologies. So technologies like this are underwater technologies that don't involve actually any contact with the asset themselves, where there's more higher risk. So yeah, want to know where those test cases are, and then we can help going out to the sector and find the solutions. Yes, so when will this become large scale? So we do have a poll on this later on, so I'm not sure if I want to ruin that, but yeah, I'm going to save that one for the poll. Okay, so how are we doing for time? 25 more minutes, right. So Claire, if we could go on to the polls again. Back to the slides, actually. Okay, so we're going to run 3 consecutive polls. I think you're all used to it now. So the first one is basically what was just asked. Poll 5 is, when do you think autonomous systems will become commonplace? And we've got some multiple choice there to make it a bit easier. So if you could maybe just give a blast at that one. Any more for any more? Okay, so, right, okay. 0 to 5 years, interesting. So it seems predominantly we're looking at shorter scale. So I think our take on this is just what I was alluding to there, is that I think these systems will become commonplace in the next 0 to 5 years, or start to become, more integrated for doing surveys and inspection. So in less invasive work, especially things that can do that based on remote sensing, so no need to actually require the turbine to be shut down or require access to that turbine or the balance of plant. So less invasive technologies, I think, will be coming in the next 0 to 5 years. But beyond that, beyond 5 to 10 years, there is a huge potential to use autonomous systems for actually doing maintenance. So going out there, repairing things, doing refurbishments, exchanging materials. But I think that really is a bit more blue sky. But the only way that we can accelerate that is by working with industry to tell us where are the areas that they would seek to introduce some of these systems. So we can then gather all the opportunities, and then we can then feed that back to the supply chain, because I'm sure these technologies exist. For most of these applications, the technology exists in some other sector, defense, transport, oil and gas. It just needs to be optimized and applied for offshore wind. So as long as we understand where the opportunities are, the Catapult can help to push that out to the supply chain and academia and try and bring some of these timelines a bit further forward. Okay, so we'll go into the next poll, which is another multiple choice. In the next 5 years, which of these O&M areas, which isn't comprehensive, but which of these O&M areas will see the greatest impact from autonomous systems? So we've got blade inspections, subsea survey, internal monopile inspections, and O&M decision making. So the bottom one is more on the data analytics. So automation of data analytics to help inform your O&M decision making. Okay, it's pretty good. I think, yeah, I would definitely agree with the poll. So blade inspections for sure, because these are already being used, but they're by far commonplace. Companies are looking to use them, but the main technique is still predominantly rope access. There's, apart from that requirement to go and access the turbine, everyone's comfortable with that technique. They've been used in lots of potentially challenging conversations between an OEM and an operator around what and what is not included, potentially in a warranty agreement. So people are comfortable with that. You can get very close and get a good quality picture. So although there is huge potential and they're being used, we still need to work on understanding the variation in performance and how you optimize these systems. O&M decision making, good. I'm glad to see that came out second, because I think there is a lot of data science, data analytics that is not being used. Perhaps that's, there is a skills shortage within the sectors. There's not enough companies such as operators and manufacturers or anyone managing an asset, hiring enough people with data science skills. But I think suddenly digitalization is a big buzzword. It's as if data was invented overnight. So everyone's now thinking about data and hopefully investing in this. And I think for sure that's potentially got a much shorter timescale, because it's not really, there's not too much risk to your assets there. It's just proving that you can trust it. And then, yeah, I think I would probably put Subsea Survey ahead of internal monopile inspection because that is something that is done more frequently by the operator. If you're thinking about an opportunity, Subsea Survey is something that is done very frequently, every 6 months or so. It's a big requirement in operating an asset is to go and survey the seabed, make sure there's no scour around your foundations or your cables or general scour around the wind farm. So Subsea Survey, I think, has a massive business case for this and is definitely has the market. In terms of monopile inspections, for sure, people need to know stuff about the integrity of their monopiles, any issues, but I would say it's not as frequently done as Subsea Survey. So yeah, okay, thanks for that. So we're going to move on to, don't worry, no more Slido now. It's all on us. Claire, if we could go back to the last. Oh no, sorry, this is the best question actually. Forgot, there's one more question. So you're totally, offshore wind aside, outside of work, where would you like to see autonomous systems? So other than being at work, where would an autonomous system help you? It's a very open question, this one. Anyone got any ideas? Cleaning my house, right up there. Yep. Good one. Commute, okay. So driverless cars, they're right around the corner. No pun intended there again. Any others? There's one that probably everyone's thinking of, but it's too scared to put up. Golf. Yeah. Replace yourself with an avatar autonomous system. There. When you're lost, finding lost balls. Yeah. Oh, that's a really good one actually. I'm a golfer myself. That would be quality. Little robot that scurries off and finds your ball. I like that one. Okay. Right, they were all very, very good and no too highbrow ones there, so thanks a lot for that. Okay, right, so the poll is over. We're going to move on now. Okay, so this next session, I'm going to quickly introduce with one slide and then I'm going to hand over to my colleague David Thompson, who's been doing a lot of work in actually working with the drones that we've purchased at our turbine. So this is all about application of drones for turbine inspections, primarily blade inspections. So I'll just quickly introduce this one. So this is an introduction to some of the drone activity ongoing at ORE Catapult. So you may not be aware, but we operate the Leavenmouth demonstration turbine. So that's a 7 megawatt turbine that was designed and manufactured by Samsung, who installed a demonstrator just off the coast in Fife, in Meffel, or Leavenmouth, and they operated that turbine for a number of years and then decided, well, offshore wind's not for us. So we took on that turbine and we use it as a demonstration asset. So we do generate electricity, but primarily it is for allowing companies to come and test, demonstrate, validate their technologies in a non-commercial environment and give companies the evidence they need to access the sector. So this turbine is an ideal asset for us to start demonstrating, testing, and developing some of the rigorous guidelines required for autonomous systems. And most of the work we've been doing today is on unmanned aerial vehicles. One of our colleagues, Tony Fong, actually is a drone pilot, so that helps. And we've been doing some work there. So we have the turbine. As I said, it's open access. If you're interested in using it, you can use it, but it does come at a cost. So if you're involved in one of those public funded competitions, catapults are 100% funded by the grants. So that's a great way to work with us and get access to the turbine. And we're doing a lot of projects around innovation, but we're also trying to develop some industry guidance around the use of drones. So RenewableUK are really looking around the logistics, the integration, but what we're focusing on is the performance. So how can you guarantee and how can you prove and assess the performance of a UAV for doing a blade inspection? You're up against a rope access technician. How can you gather the same or better data? There's no current way of how you can pre-qualify that. And we got feedback from the industry that they would like some way because they're getting a lot of companies trying to gain contracts and there's no way to pre-qualify them. And there's a lot of companies now out there trying to do this work. So that's one area that we're trying to use the turbine. So that's an introduction to the turbine and our background. So I'll pass over to David to talk about some of the technical work we're doing.
Okay. This one. I think we're on. Okay, so I'm going to talk quickly about what we've actually been doing with these drones here at Leavenmouth. First of all, the flights that we've done haven't been particularly different from any normal drone inspection of a blade. What the difference with what we've been doing is in the post-processing. Because we have access to this turbine and the data from it, we can combine that data from logs from the drones themselves and get a bit more value out of the photos and the inspection data. So what we can do is use position data and the direction of the camera from the drone, combine that with SCADA data from the turbine itself, the yaw angle and the rotor position. We can, from each of the photos that comes out of the drone, we can get information like the blade position, whereabouts on the length of the blade that this photo is of, the distance from the camera to the blade, and using that we can work out the size of an individual pixel on the photo, and therefore get a lot more information about any damage or features on the blade that we want to get information about. So I'll show you this little tool that we've developed. The video's playing. So these are the photos from the drone on the right, and on the left here you can see the turbine. Now in this case it was idling, so you can see the blades moving a bit and the turbine yawing, which is the big pink plane. And you can see our drone moving about up here and the direction that the camera was pointing and where that intersects the plane of the rotor. And on the bottom right there is a bit of information. There's just a histogram that represents the light levels in the photos, and that allows us to make some judgments about the quality of the photo, which we'll come on to speak about a bit later. But getting some benchmarks for photo quality of drone inspection data is something we want to take a bit further. Now, using this data, we can do a lot more work with the post-processing. But to take that a bit further, what can be done in the future is if we can get a link between the drones themselves and the turbine whilst it's actually flying, then we can do all this stuff in real time. And it will allow us to do things a little bit more clever with the flight, like actually autonomously pointing the camera gimbal. So you can see on the right-hand drone there, you've got the camera hanging down, and it can move in 360 degrees in both planes. If you could just fly the drone by itself, and the camera will aim itself at the blade and get all the photos you need, that would improve the quality of the data we get. What you can see on this photo, you see the drone on the right, which was a bit of a speck. This was our view when we were flying the drone and doing this inspection. You can see that it would be quite hard to fly that up and down just visually and trying to get a good scan of the blade. In this case, we had the sea is here, so you couldn't get around in front of the drone, have a good look at it, and there's quite a strong crosswind. So if we could improve if we could make this easier using a bit of autonomy, then that gives us a lot more value from the inspections. Okay, so Andy's going to talk a bit now about the developing metrics for improving the quality of images.
Cheers, David. So I'll just finish off with this. Just as a sort of disclaimer, so we're not seeking to be a blade inspection company. We have definitely have an unfair advantage by having a massive 7 megawatt turbine to play about with. So we're not intending to be a blade inspection company, but what we're trying to do is develop technologies that are methodologies that could be adopted by other UAV service providers, and also try and best understand our asset and how drones capture images of that asset, so we can feed into guidelines for the industry. Hopefully, supporting some of the work RenewableUK are doing, looking more at the performance we have this turbine, so we can do some experimental work, data-driven guidance around how you can validate the performance of the images that are coming from the UAVs. And that then helps industry end users to basically pre-select companies. They can run these tests, they can provide that evidence. It provides the security for the customer and also for the UAV service developer. If you're not already in the sector, you get a basic understanding on the minimum requirements. So this is what industry expects. This is what they would require for you to be a provider, and this is how we want to see that evidence. And you could come to our turbine, or these types of tests could be done on any turbine or any other kind of way. You don't necessarily need to use a turbine. So we're trying to develop those methods. So this is all about guidelines and validation. So what we've done is we're using these drones to benchmark the defects on the asset. We've established a group of UAV technology and service providers who are going to come to the asset and take part in some trials. So we're going to run a number of trials of different UAV technologies, inspecting the turbines in different conditions, from different operational levels, different operational envelopes, different times. So, obviously you don't get all day to do inspections, so what's the difference in quality if you do it, say, in half an hour compared to 2 hours? What happens when there's plenty of cloud cover compared to a bright day, etc. When the wind levels go up, we want to assess how that affects quality and then work with our industry end users. So we've got operators, manufacturers taking part who would say, those images we would accept, those images we wouldn't accept. And this is the conditions that we want those images to be gathered in. We can then take the good images and develop some of these metrics that David was just illustrating around how you would assess the tolerance on the pixels per millimeter, the contrast, the brightness, things that would help determine the accuracy of the image. So looking at things, how would we quantify the difference between that and that? How could we provide a scientific and quantitative way to assess the quality of a UAV service provider rather than just based on qualitative, well, that looks better than that. So that's really what we're doing at the minute. We're doing trials towards the end of this month and into the next month, July, into next month. And hopefully, once we've processed a lot of that information, we can work with the likes of RenewableUK to start introducing some official guidelines into the industry. Okay, so the last section is going to be doing a little simulator that people could actually have a go at. But while we set up, is that working? Video should be working. Oh, sorry. We should have a nice video here. There we go. There's the music. Okay, so please enjoy the video, and while that happens, David will set up the simulator, which we'll spend. Oh no, the video's gone. Oh, well. We'll spend the last 9 minutes with our simulator. I'm really sorry the video has failed, but never mind. Okay, so please just allow us 3 minutes to set up the UAV simulator, and then that'll be us. All good? How do you connect that up? All right. What, the VGA? So, would anyone like to come and have a go? Any volunteers? Ailey. I'm going to put it on you. So, this is the actual drones that are connected in. We need to use the drones for this, but we can't just fly these things around, unfortunately. I'm sure John wouldn't be happy about that. So, this is just a wee simulator that we have set up to help people who've maybe never flown a drone or piloted a drone, same thing actually, to have a wee go. So how's that, Ailey? Brilliant. So I think, Dujon, maybe we'll hand over to the next speakers, and while doing so, if anyone wants to come up and have a razz on our simulator here, please feel free to do so. But first, I'd like to thank you all for attending and taking part in the polls. And if you have any further questions on autonomy and working with the Catapult, please come and find us. We do have a stand out the front. Thank you very much.